I want to do a brief overview of how to do machine learning. And this is the very high level overview after my Udacity machine learning nano degree, which is definitely do a review on that soon. So nano degree. Generally, the library we use in this context is Scikit-Learn. It's like a beautifully written collection of libraries of algorithms you can use, or learner models. Such items like decision tree, and random forest, neural network, and etc. etc. So you get the idea. Usually it follows this pattern. You want to say classifier, first import. So usually from sklearn import, let's say decision tree. It's not going to be this simple, but you get the idea. And then you want to set a variable, that's your classifier, equals to random forest classifier. And you usually go read the documentation, and in this argument parameter, you can add your own parameter to fine tune the model. And then you usually want to call a fit function on this. And you usually want to do it on xtrain. So that's your training data, also your training data white label. So in this case, classifier will be female 21, and the classifier is attending college. And the answer is either yes or no. So this age range seems okay. And then male 16, is he attending college? Likely, that's a no. So unless it's a prodigy. And then what you want to do is use this classifier which you train. So this is where really the machine learning happens. It's learning this data, whatever data you feed it. And then it learns to predict this Y column. So this is our X train. This is our Y train. And then what does it want to predict? It's usually X test. Okay? And then, so what does X test mean? So imagine in X train, we really need a whole lot more data than this. We can't just have this many, but you get the idea. Let me grab another board. We ran out of board. Imagine now we have a test data. So imagine we have many rows of data like what we saw earlier, college or not. And now we have this test data. And then it says it's a female or male. By now you probably know it really doesn't matter. And the US college gender attendance is pretty similar split, and of course, there's argument how well it's represented. But for this example, we say X data probably is less important, and there are ways to figure it out. But that's not the point right now. As you can see, where I'm getting at is the age. If it's 15, what do you think the predicted label would be here? So ideally, we wanted to say no, right? And then here, 22. And after lots of training, we realized that 22 is very possible this kid is in college. This one, we wanted to say no. And this one, we want to say yes. Okay, so let's go back to our first board. We're trying to predict X test. This is our X test right here. And this is the Y test we're trying to predict. Okay? We usually set this side equals to Y predict. And in the case of classifier, you usually have an accuracy score. What does that mean? It says, out of the answers I'm supposed to predict, how many did I get right? Let's imagine here, there are only 2 slots, remember? So let's erase this. Erase. Okay, so we only have 2 slots. And say, look at, this is a female. After tons of data, machine start to learn that pattern and say, okay, 15 is too young for college. Okay? And then the machine look at this data, this X test, and say male. Okay, 22. 22 is likely to be in college, so I'm going to predict yes. out of the 2 answers, did it get right? It got right. So that's 100% accuracy. If it were to get the first one wrong, then that's only 50% accuracy. So 1 out of 2 is incorrect. Okay, so you generally follow this pattern where you import the library you need to use, the model, and a lot of domain knowledge, a lot of background knowledge will inform you which model we'll use. And a lot of times it's trial and error. There are lots of papers you can read about what model is good for. It's a big learning curve there. And the fit part is easy, the predict, and then there's a scoring. In this case, we use accuracy, which is one of the introduction scoring. If that is all there is about machine learning, then why is it such an advanced field? Well, first of all, it takes a long time to prepare the data, take account of inherent bias, issues in the data, confounding factors, and correlation you often hear does not equal to causation. So there's a lot of stuff to figure out, and that's why it's not easy. And a lot of your times not only will be spending reasoning about your data, understanding the model, its strength and weakness, as well as the issues, the bias, variance trade-off, etc., etc. And a lot of times it's also how do you create this X-train, Y-train, X-test, Y-test example. These data sets matter a lot. So that's a really high-level overview of what sklibrary you will use. And the reason why you want to use Scikit-Learn is you don't want to reinvent the wheel. These machine learning models are very well used in the decision tree, neural network, etc. There are experts help to implement these great libraries. So it's very, very efficient, and it'd be hard for a beginner to go in and tune the model from scratch. And that's why you should use an existing library. But really a lot of effort, especially in the Udacity capstone, you will see a lot of your effort will be spent on training these models, understanding the nuances. It really takes quite a bit of time. So, but remember when you're going through the pset, it's really, you got the import, you got the classifier, you fit the classifier, and sometimes it's a classifier, sometimes a regressor, and then you predict, and you get your prediction, which is also y hat, another notation you will see, and then you can score it. Usually some kind of scoring function equals y pred and y test. And then this is only when you're working on the train and test data. You can imagine later on what you really want to do is new data that you have never seen, and you want to score your model against that. I have my classifier that's trained and optimized to predict some new data. Let me call it x new. So you always want to predict on the feature. And then that's my y, sub 2 hat. And then my scoring will be between my y sub 2 hat and y actual.